Similarly, take one more example. The open loop transfer function of the system is given by gh of s is equal to k by s into s plus 1 into s plus 2. Find breakaway and break-in points of the system. Now again we have gh of s, that is open loop transfer function, and we are going to locate poles and zeros. There are 3 poles available, therefore I'll take the s plane, and in this s plane I am going to locate the poles and zeros. So one pole is s is equal to 0, at origin I have one pole, and another pole s is equal to minus 1, s is equal to minus 2. So what is the root locus area? So root locus area is in between 0 and minus 1 and minus 2 and minus infinity. So once you know the root locus area, then we can use the procedure. We find out dk by ds is equal to 0 roots, and we'll do like that. The first step is 1 plus gh is equal to 0, so 1 plus k by s into s plus 1 into s plus 2 is equal to 0. Now, so that results in k is equal to minus s cube plus 3s square plus 2s, that is k, and dk by ds is equal to 0. If we solve it, you are going to get 3s square plus 6s plus 2 is equal to 0, and their roots are s is equal to minus 0.42 comma minus 1.577. So minus 0.42 minus 1.577. So 0.42, because in between 0 and minus 1 we will have root locus area, and minus 2 and minus infinity we will have root locus area. But so 0.42 is in between 0 and minus 1, therefore that point is a valid break point. Minus 1.577, it is in between minus 1 and minus 2, where we don't have the root locus area, therefore the second one is invalid break point. So what I can say, you take the open loop transfer function and form the write 1 plus gh is equal to 0 characteristic equation, and k is equal to f of s function, then you write dk by ds is equal to 0 and solve for s. So the roots are either all the roots are invalid and all the roots are valid, or some of the roots are valid and some of the roots are invalid. So all possibilities are there for the roots of dk by ds to have valid breakpoints. Imaginary crossover point. What is imaginary crossover point? The definition is, it is the point at which root locus branches cross the imaginary axis. So it is the point at which root locus branches. So generally those branches will be in pair. So those branches either 2 branches or 4 branches. So root locus branches cross the imaginary axis. So where exactly it is crossing the imaginary axis, that point is the imaginary crossover point. So imaginary crossover point is very important to find the stability of the system. Whether the system is absolutely stable or absolutely unstable or conditionally stable, what is the condition over it. So we can easily find out using imaginary crossover point. So let us see what are the different possibilities of having imaginary crossover point. It is not that every problem will have imaginary crossover point. You may not have. So what are the different possibilities? The first one we can say, if the starting point of one of the root locus branch in the left of the S-plane and ending point of the root locus branch lies in the right of the S-plane, then there is a possibility of having imaginary crossover point. That means your open loop poles may be left side and your open loop zeros may be right side, because zeros are ending points, poles are starting points. So when you have poles in left hand side, that is left of the S-plane, and zeros in the right of the S-plane. So these two will start here, they should reach the pole 0, therefore they should cross the imaginary. When they are crossing, then exist imaginary crossover point. And when you are looking at the poles and zeros, these poles need not be the real poles, they may be complex. And similarly, when I say zeros, zeros may not be real, they may be complex. That means all the possible combinations, with the real here, complex there, and the complex here, real there, anything. The other thing is, when the poles are other side, that means vice versa is possible. That means if you have poles in the right of the S-plane and zeros in the left of the S-plane, again there is a possibility of having imaginary crossover point. So we know that if zeros are not sufficient, then we are looking for the asymptote. So depending upon the asymptotes also, so we can say whether we have imaginary crossover point or not. Now whenever asymptote is moving from left half of the S-plane to right half of the S-plane, that means if the asymptote itself is crossing the imaginary axis, then certainly there will be imaginary crossover point. So again same thing, so the crossing may be from the left hand side to right hand side, from LHS to left half of the S-plane to RHS right half of the S-plane, or from the right half of the S-plane to left half of the S-plane. So if your asymptote is crossing, and one of the root locus branch should follow the asymptote, therefore your root locus branch will also cross the imaginary axis. So whenever you have a problem, then we need to look at these possibilities. If these possibilities are there, then we try to calculate imaginary crossover point. Otherwise you need not calculate imaginary crossover point. Let us see what is the procedure to calculate imaginary crossover point. Now we know the procedure very easy, we already seen in Routh-Harwich criteria, so we'll use the same thing. The first step is write the characteristic equation. So we know that 1 plus GH is equal to 0 is the characteristic equation. Then form Routh array. We know how to form the Routh array. Then calculate K value such that system gives marginally stable condition. Means there must be a one row which is having all 0 elements. So we need to calculate K value such that one row should have all 0 elements. Then at that particular value of K, then you will get the imaginary crossover point. Then how to find the imaginary crossover point? Before that, if this particular K value is not real, so not your positive, that means if the K is negative and complex, then there won't be any imaginary crossover point. So this K value must be positive and real, then only you will get the imaginary crossover point. Then how to find imaginary crossover points? Now when you make one row 0, so just above the row is the auxiliary equation row. So from that coefficient, then we can write the auxiliary equation, then find the roots of the auxiliary equation. So whatever the roots you are getting from the auxiliary equation, and those roots are imaginary crossover points. So this way we can easily find imaginary crossover point. So to understand this rule, let us take this example. So the open loop transfer function of a unity feedback system is given by g of s is equal to k into s plus 4 divided by s into s plus 2. So this we already seen, but to calculate breakpoints. Now in this case it is imaginary crossover point, k into s plus 4 divided by s into s plus 2. So what we'll do, first look at the possibilities. When you locate poles and zeros, so I have one pole at origin, one pole at -2, and there is one zero at -4. Okay. Now how many asymptotes you will get? The first thing is all poles and zeros in the left of the S-plane. If at all one zero in the right of the S-plane, yes, there will be obviously one imaginary crossover point. But in this case, my poles and zeros all are in the left of the S-plane. Now look at the asymptotes possibility. So we have 2 poles and 1 zero. Therefore 2 minus 1 is there will be only one asymptote. And we know that asymptote, if you have one asymptote, the asymptotic angle is minus 180 degrees. Therefore, so wherever it starts, the direction which will go towards the negative infinity only. Therefore, so when it is going negative infinity, so my root locus branches will also go towards the left direction. There is no possibility of crossing the imaginary axis. Let us check it. Let us check whether this possibility is correct or not. Okay, here we don't have any possibility having imaginary crossover point. Now, what are the steps to be followed? The first step is write the characteristic equation. So if you write characteristic equation, you are getting it is 1 plus gh is equal to 0, which results in we have s square plus s into 2 plus k plus 4k is equal to 0. Simple second order equation. Then this is the Routh array. I have s square, s plus 1, s power 1 and s power 0. So 1, 2 plus k, 4k and 0. And what will be this? This obviously will be copied from there to here, carry forward. This is 4k. And what are the first column elements? Now I have 1, 2 plus k and 4k. So you always try to look at a row which is having odd number, that means s power number is odd, so that row you try to make it 0. Therefore the next just above the row will be even row. From that we can find out the auxiliary equation. So always the possibilities are either s power 1 or s power 3 or s power 5. So generally we go for only s power 6, therefore the possibilities of having auxiliary, one row with all 0 element is s power 1 row and s cube row. So let us test here also. We'll look at all the possibilities. The first one is s power 0, 4k is equal to 0, k is equal to 0. So when you put k is equal to 0 and the last row is only 1 0, but we should take the s power 1, therefore this row cannot be 0. Let us take second condition, 4 plus k is equal to 0, k value is 2 plus k is equal to 0, k value is minus 2. So k cannot be negative, k should be always positive and real. That means you cannot make, with all positive value of k, we cannot make any row with all 0 elements. What does it mean? It indicates that in this particular problem there are no imaginary crossover points.